Olá pessoal, estamos em mais um SBU in situ aqui em San Antônio, Congresso Americano de Urologia, e agora eu vou entrevistar um grande amigo, Dmitriy Nikolavsky da Upstate University, e o Dmitry vai falar para a gente sobre as novidades da cirurgia reconstrutiva. Ele é um grande entusiasta da endoretroplastia. Dmitry, talk about the news and the poster on the use the catheter uretra with fototerapia. Congratulations for winning the best poster.
Muchísimo obrigado. And the rest will be in English, sorry. So this was a very, very preliminary, we call it pilot study. The idea was very simple. There is something called photobiotherapy or phototherapy that already existed for many years outside the body to treat the scars or wounds and certain wavelengths of the light. Red light or near infrared light was found to be beneficial to expedite the healing of the skin wounds, expedite the vascularization, diminish inflammation, and maybe somehow modulate fibroblasts. So the exact recipe, is not known yet. What exactly is the duration of therapy? What exactly is the perfect wavelength or power? But we decided to use this idea, in the urethra. So we took some of these numbers, like how many joules of power for so many minutes. We decided to go with two wavelengths, red light, which is 650 nanometers wavelength, and another one is a near infrared light, which was 810 nanometers. And just repeat the same study that people do on the skin to get rid of the scar, and use them in the urethra. But for that, of course, we needed to have first animal model. For us, it's a rabbit that we developed the stricture. And we had to develop a special tiny little catheter that has a transparent body, and to have the fiber optic that would deliver the light. And we would have to calculate how much of this light would reach the stricture. So we would do rabbit with the stricture. We would do a DVIU, direct vision internal ureterotomy, with the tiny little instruments, pediatric instruments in the rabbit. And then half of the rabbits, we would get, actually, there are three groups. 33% of the rabbits, 5 rabbits, would get red light treatment for 1 week. Another 5 rabbits would get near infrared therapy for 1 week. And there is a control group that had just a catheter. Exactly the same looking catheter, but not connected to the light. And then we removed the catheters and waited for another couple of weeks. And unfortunately, we sacrificed the rabbits, but first we would do cystoscopy, and we would do retrograde ureterograms. The imaging we sent to pathologist for a radiologist who didn't know which group is what. So radiologist was blinded to the group to avoid bias. And then we sacrificed the rabbits and sent the pathology specimens to the pathologist who also didn't know which group is what. And we looked for, with the radiology, we saw how bad or how good the stricture is now after the treatment. With the pathology to see, how much inflammation, how much stenosis, fibrosis, how much vascularization, and compare the groups. And it was kind of interesting that from the very first try, we saw that the rabbits that were treated with, I believe, with the near infrared light did better on pathology, the rabbits with the red light, if I'm not confusing, I don't remember exactly, it's a long week, did better with the resolution of strictures. It was very surprising. Almost all of them got at least 50% better or completely cured after this treatment. So there's so much work to do next. We first of all need to prove that that was true. So we need to repeat the experiment in maybe a larger group of rabbits. We might have to commit to say maybe we will go with the red light this time only, or maybe repeat exactly like the same. We need to then tweak every parameter. How long is the therapy? How much energy? Maybe we need to turn the light more, maybe to decrease it. But in general, we know that the light can modulate fibroblasts and epithelial cells to behave the way we want. We just need to know which parameters to adjust. And then the next step after this will be to create the same kind of catheter, but a little bit bigger for humans, and to have a human trial once we know what we're doing. But I would suggest don't rush to immediately do it in humans, but because we don't know exactly the settings. We need to have a recipe. It's like when you bake the bread, you need to know all the ingredients and how long do you bake. So this is the same thing here. It's very exciting, but it's very, very early. Muito obrigado.
Finalizando aqui, o Dmitriy é um entusiasta da engenharia tecidual e eu acho que a cirurgia reconstrutiva ela precisa melhorar e os avanços na engenharia tecidual, como o uso de célula-tronco ou o uso de fototerapia, é uma alternativa que vem ganhando importância, e queria agradecer ao Dmitriy, um grande amigo, trazendo as novidades, e mais uma vez parabéns que ele foi eleito o melhor pôster da sessão. Queria dar parabéns para o Dmitriy.
I just want to add something. Can I add something more? Yes. So also after that, we will need to find out what is the best application. Is it to just treat the stricture like this after DVIU or dilation? Is it going to be improvement of outcomes of urethroplasty? Imagine you did urethroplasty and then you put this catheter maybe to improve the healing. Is it the catheter that will be placed after prostatectomy to shine that light at the anastomosis? So there are many. So first, we need to see if it works. And once, let's say if it works, we need to find which conditions could be improved. DVIU, dilation, prostatectomy, maybe post-TURP, post-transurethral resection. Maybe you improve the epithelialization faster. So it's very exciting, but once again, it's too early to celebrate.
Congratulations, Dmitriy.